Hey everyone, this is your triangle proofs review. Okay, in the beginning you're going to have some useful information that you can reference while you work on this packet. The first is your different types of congruency. We have side, side, side. We have side, angle, side. We have angle, side, angle. And we have angle, angle, side. And notice that they're all demonstrated, within the triangles themselves. It's very important to remember that you cannot prove triangles with angle, 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 or SSA. Those are no good. When it comes to setting up your proofs, you have your statement column on the left-hand side, and you have your reason on the other side. Okay, your intro is usually listing your givens. Then your body is usually the properties and the theorems that we know to help prove the missing angles and sides. And then your conclusion, especially in this chapter, is going to be saying that those two triangles are congruent by either side, 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 angle, side, angle, or angle, angle, side. Okay, the first thing that we're going to look at are some common properties and definitions that we've learned in class, and that would be useful to us during our proofs. Okay, the reflexive property. When the triangles have an angle or a side in common, AB is equal to BA. Number 2 is vertical angles. Those are our bow ties, okay, when two lines are intersecting. Number 3 is right angles are always congruent, as they're always going to be 90 degrees. Number 6, the definition of a midpoint means that there's two segments that are congruent. Notice if the red dot is your midpoint, then KJ and JI are going to be equivalent. The definition of an angle bisector results in two angles being congruent. So if you were to cut the giant angle BDF in half, then BDH is going to be congruent to FDH. And number 8, the definition of a perpendicular bisector. Well, bisector and perpendicular means that it's going to create two right angles. Okay, we also have alternate interior angles, which is one that you guys know already. It's alternate sides on the interior of a transversal cutting through two parallel lines are going to be congruent. On the bottom left corner, you have the definition of a segment bisector. So if you cut a segment in half with a line, then TQ is going to be congruent to QR. And last, your third angle theorem. If they give you two angle pairs congruent, then you know that the thirds must be congruent. Okay, and the most important thing is right down here in the bottom, do not assume anything if it is not in the given. We either need to state it to prove it ourselves, okay, or it's going to be in the given. We can't just assume. All right, so it says, check which congruence postulate you would prove to solve the two triangles congruent. Well, I see side, 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 and side, side, side. So this must be choice 1. Number 2, I see side, angle, side. And on the other side, it's the same. Side, angle, side. SAS. Okay, here we have an angle followed by an angle followed by a side. An angle followed by an angle followed by a side. Angle, angle, side. Number 4, we have an angle, a side, and an angle, and it mirrors on the other. Angle, side, angle. Number 5, we have 3 sides congruent to 3 sides. Side, side, side. Okay, writing proofs. We have a few givens here, okay, that angle YLF is congruent to angle FRY. So why don't we plug those in? YLF is here, FRY is here. Okay, and they labeled that in number 1, so that is your given. You have another given, though, that angle RFY is congruent to LFY. Well, RFY is right here, and LFY is right there. So again, that's going to be a given statement. Then we know that these two triangles share the line FY, which means I'm going to put an X on it for reflexive. Okay, so your reflexive property. So now that you look, we have angle, angle, side. So these triangles must be congruent by angle, angle, side. Okay, I'm not going to do all of these examples. I'll do a few for you. Given LT is congruent to TR. Then we have angle ILT is congruent to ETR. Okay, then they're going to tell us that IT is perpendicular to ER, which is also a given. And what they like to show with perpendicular is arrows. Okay. Now, number 4 says angle LTI is congruent to angle ERT. Okay, and since those are parallel lines that are cutting through, those are going to be corresponding angles. Think back to our last chapter. Okay. So if we look, we have an angle, a side, and an angle. An angle, a side, and an angle. So our two triangles must be congruent by ASA. Number 8 says, given C is the midpoint of BD. That's your given. Okay, since it's the midpoint of BD, well, we'll get there in a second, actually. AB is perpendicular to BD, which means this creates a right angle, so put your box in there. Okay, so we have our given. Then they tell you BD is perpendicular to DE. What's up? Which means that you have a right angle at D. Thank you, man. Okay, your next statement says BC is congruent to CD. And that's because of this midpoint statement. So write definition of a midpoint. Okay. Then we have angle BCA being congruent to ECD, and that's your bow tie. Those are vertical angles. Okay. Then they stated ABC and EDC are right angles. Well, that's because of your perpendicular statement. So write definition of perpendicular lines. Last, we have ABC congruent to EDC, and again, that's because of step 2 and 5. All right angles are congruent. We're finally going to get to say that the triangles are congruent, and I see angle, side, angle being our congruency. Okay, number 9. Given that BA is congruent to ED, we're also given that C is the midpoint of BE and AD, which is a given. Okay, now these two statements are going to play off of statement 2, that BC is congruent to CE and that AC is congruent to CD. Okay, and we're just going to write definition of a midpoint. And from what I see in the picture, we have side, 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 congruent to side, side, side. Number 10, we have BC being congruent to DA. Oops, sorry guys. And that was a given. Then we have AC bisecting BCD, also a given. So since it bisects, we could say that angle BCA is congruent to angle DCA. That's the definition of an angle bisector. Then we have AC being congruent to AC. Well, that's reflexive. So when we look now, we have side, angle, side. Okay, side, angle, side. All right, so 11, 12, 13. You need to be able to write these proofs on your own. So give your statement and your reason chart. And remember, go back to the beginning if you need help. You have your intro, you have your body, and you have your conclusion. Okay, your givens are angle ADB and angle CDB are right angles. And that's a given. And to make things easier, I would label. Step 2 said that angle A is congruent to angle C. Okay. So we have our congruent angles and we have our right angles. Next, you would say that BD is shared by both triangles, so it's congruent to itself, and we call that reflexive. I see angle, angle, side, angle, angle, side. Triangle ADB is congruent to triangle CDB by angle, angle, side being congruent to angle, angle, side. Work on the rest on your own and submit it when you are completed.